Generative AI isn't just another advancement. It represents a fundamental transformation in how technology interacts with human creativity and problem solving. With its ability to generate text, images, code, and even multimodal outputs, it blurs the line between human and machine contributions. Google Cloud, leveraging its state of the art AI research and infrastructure, has introduced four new generative AI learning paths. These programs are designed not only to teach, but to strategically position you to innovate, implement, and scale generative AI solutions effectively. Today, we'll deconstruct these paths in technical depth, align them with practical applications, and explore how they fit into the larger technological and economic landscape. By the end of this session, you'll have a clear understanding of how these paths can empower you or your organization to stay ahead in an AI first world. In our first section, we will discuss the generative AI landscape. In regard of unprecedented growth and adoption, we take transformer models as catalysts at first. Since the introduction of the transformer architecture in 2017, the pace of generative AI advancements has accelerated. Models like PAL-M2 and GPT-4 achieve human-like performance on tasks that were previously considered unsolvable. Multimodal evolution. Tools like DALI and Imagen push the boundaries of what's possible by generating cross-modal outputs, such as combining text with visuals. For strategic necessity, businesses are no longer asking whether to adopt AI but how fast they can integrate it. Generative AI use cases now include synthetic data generation for machine learning, automating design pipelines in manufacturing, creating dynamic personalized content in marketing and education. Let's continue with bridging the talent gap. Google's learning paths are critical in addressing the growing demand for talent skilled in building and deploying generative AI solutions. By democratizing access to cutting edge AI knowledge, Google is not just closing the talent gap, it's building a robust global AI ecosystem. Fourth, Introduction to Generative AI. This foundational course builds the conceptual framework. Let's break it down. Mechanics of generative models. The course explores architectures like autoencoders, GANs, generative adversarial networks, and transformers, emphasizing how these structures differ and when to use each. Advanced tokenization. Delve into subword tokenization methods like byte pair encoding, BPE, and how they impact model efficiency. Hands-on experience. Fine-tune an encoder-decoder model. Experiment with probabilistic sampling techniques like top-K sampling and nucleus sampling to improve the diversity of generated outputs. Strategic takeaway. Understanding foundational models equips learners to ask the right questions. How can generative AI be optimized for specific data sets? What are the trade-offs between computational cost and output quality? Generative AI for developers. Taking a developer first approach, this path empowers you to operationalize AI. Building with Vertex AI. Learn to use Vertex AI's pipelines for end-to-end workflows. Explore auto MLwares. Custom training, when to prioritize speed over control. APIs in depth. Gain mastery over tools like text to image API and generative code API. Understand latency management and multi-threaded deployment strategies. Model fine-tuning at scale. Learn techniques like LoRa, low-rank adaptation, for fine-tuning models with fewer parameters, reducing computational costs. Example projects. Develop a virtual assistant that can understand and summarize user queries in real time. Build a generative design tool for industrial applications, automating the prototyping process. Trece. Responsible AI with generative AI. This path stands out by combining technical depth with ethical rigor. Best quantification and mitigation. Explore real world case studies of biased generative models and how these biases propagate across systems. Use statistical fairness metrics like demographic parity and equalized odds to evaluate outputs. Explainable generative AI. Implement techniques to make outputs traceable. For example, using activation atlases to visualize model decisions. Compliance and governance. Align AI systems with frameworks like ISO IEC 40001. Prepare for evolving regulatory landscapes such as the EU's AI Act and NIST's AI Risk Management Framework. Strategic takeaway. Responsible AI is not just a moral imperative, it's a competitive differentiator. Organizations with transparent and ethical AI systems are better positioned to build trust and navigate regulatory challenges. Advanced generative AI use cases. For seasoned AI practitioners, this path delves into high impact, specialized use cases. Custom model design. Train large language models with distributed training strategies, leveraging frameworks like JAX and PyTorch Lightning. Use adapter layers to modularize learning for different tasks. Inference optimization. Apply techniques like distillation to compress models for edge deployment. Explore zero shot learning for rapid prototyping across domains. Industrial applications. Implement generative AI for drug discovery pipelines simulating chemical interactions. Use neural architecture search NS for hardware aware model design. Google's platform provides more than knowledge, it's a strategic enabler. Scalable infrastructure. Train and deploy models on Google Cloud state of the art TPU clusters. Integrated ecosystem. From BigQuery for data processing to Vertex AI for deployment, the learning paths align with Google's AI ecosystem. Real world impact. Labs simulate production challenges, ensuring learners graduate with practical, deployable skills. Computational efficiency. The courses emphasize cost efficient techniques such as gradient checkpointing and parallelized training to tackle the computational expense of generative models. Interoperability. Cross platform frameworks ensure seamless integration of AI tools with existing systems. Scalability. Learn how to implement containerized AI models for scalable deployment across cloud, edge, and hybrid environments. Retail. Use multimodal generative AI to design custom product campaigns. Healthcare. Apply bioinformatics driven generative AI for protein folding simulations. Finance. Build fraud detection models capable of generating synthetic adversarial scenarios to stress test algorithms. Mastering it. By integrating foundational knowledge with hands on practice and ethical principles, these courses empower individuals and organizations to thrive in the AI driven future. Whether you're a developer, a researcher, or a strategist, this is your opportunity to not only stay relevant but to lead. Take the next step with Google Cloud Skills Boost and position yourself at the forefront of the AI revolution.